All right, here we go. Exercise 7A. We're exploring parabolas. Now, parabolas is y equals to x squared. Some of you might have seen this, especially if you were studying to get into the selective entry schools. The next step from linear equations is y equals x squared. So you started off by learning in year 7, so I'll just do a timeline. Year 7 and 8, normally mainstream, you learn algebra, just the basic concept of using letters to represent a number. Then usually in the mainstream, by the time you get to year 9, you then dabble a bit more into linear equations. My year 8s, I actually introduced them to linear equations, but that gets mainly used in year 9 mainstream. You guys being accelerated, I assume you guys would have done it in year 8 last year. And what you would have seen is something like this, y equals mx plus c, right? But if I strip out the m and the c, which are called parameters, technically it's just y equals x. Notice the difference between the two, that in year 9, the first graph, or the first part where we're using algebra to represent a pattern, is a y equals x line. This one is to the power of 1. So that's linear. Then you go into year 9 and year 10 mainstream, you then master what we call quadratics, which is to the power of 2. The shape of the graph is called parabolic, but the equation itself is called a quadratic equation. So this is called a linear equation. This is called a quadratic equation. So here, this is linear equation, and this is a quadratic equation. The point that I'm trying to get at is the highest power of the function dictates the shape of the graph. In this case, when you have the highest power being 1, it ends up looking like a linear pattern. So it's linearly growing up or going down or whatever it is. It's a straight line. Whereas an x squared, if the highest power in your expression is an x squared, it will have this parabolic shape that looks symmetrical on both left and right. And the reason for it is when you square a number, no matter what the x values are, if it's -1, -2, -3, the values are actually the same for both the positive and x. So an example would be like y equals, if I subbed in 2 squared, actually I'll put 3. 3 squared gives you 9. But if I said y equals to the -3 squared, it also equals 9. That means on the graph, when x equals to 3, y equals 9. That's the first point you get. But it also means that when x equals -3, I don't know what's happening there, you also get the same point. And because of that, if it's 4, you get 16, and -4 gets you 16. That's why you get this parabolic shape. It's symmetrical. Because whatever you do to the negative, it actually is a reflection of what happens in the right side. So keeping that in mind, today's lesson, if we are understanding that this is the highest power, if it's a 2, it's a quadratic equation, and it gives you a parabolic shape, then with that shape, what can I do to the equation that changes the shape? And that's all it is. The shape will always be parabolic, but you can make it a thin parabolic, you can move it away from the x-axis, you can move it both towards the top right corner of the axes, or the quadrant 2, 3, or 4. You can even flip the graph upside down as well. What can you apply to this equation to change that? That's what we're looking at. Okay, so I'm going to show you the things that you can look at. How can you change a quadratic equation to change the positioning or the shape of this parabolic shape? Okay, so that's what the A, the H, and the K is going to be responsible for. So whilst I'm giving you all those examples there, I'm just going to rub this section out so we can focus on the key parts. Notice in this expression that I've given you, in this expression, the highest power is a 2. So that's a big indicator to you straight away that this is a quadratic equation. Okay, everything else is called a parameter. A is a parameter, H is a parameter, and K is a parameter. And a parameter means is if the shape is a quadratic, parabolic shape, what do the parameters do to the equation? That's what I do in Desmos. So when I put A, H, and K, it has all those possible numbers that it could affect this graph. Now, each one does have a specific effect on the shape of the graph. And that's what I want you to learn. Okay, so here we go. Easiest one to remember is actually working from right to left.
So is there like, wait, so can the power be like higher than 2, or does it always have to be 2?
If you want it to be a parabolic shape, it has to be 2. But if it's a 3, then it becomes cubic. And that's where at year 11 we teach them cubics. I taught them this term. And then once you know cubics, so you've got an even power. Whoops, let me just fix that. You've got an even power, you've learnt an odd power there. And once you learn cubics, you can technically do x to the power of 99. Because it's only 3 things that you only need to know these 3. And there's a pattern when you get to x4, x5, x6. And that's why we mainly focus on the algebra of linear, quadratics, and cubics. Once you learn those algebra really well, you can apply it for any other functions afterwards. Yeah. They're called polynomials. The big term for it, which I remember when I was in year 10, there was this year 11 student who told me, he's like, oh, you're in year 10, wait till you get to polynomials. And I had no idea what that meant at the time. He said, you are going to struggle and you're going to die. And I was like, oh, okay. What I didn't realize what he was trying to say was polynomials just simply meant, this is all called polynomials. Let me just spell that again. Polynomials. All he was just saying is x to the power of something. And you look at the functions. But if you learnt linear, quadratics, and cubics, technically you can do it to the power of anything. Okay, so that's what polynomials are. Yeah, oh, that's a good question. Maybe you can start seeing a pattern. Let's see if you guys can see a pattern. Okay, so I'll draw a linear. This is linear, so x1. I'll do an even pattern over here, x squared. Cubics look like this. Quartics, so this is x cubed. Quartics looks like this.
Oh, yeah. I remember this.
X5.
Wait, I think X6 will look like X4.
Why is X5?
Oh, yeah.
So cubics are
Oh,
odd.
yeah.
Now, let's just looking at odd powers and even powers. What's the first thing that is very apparent to you? There's one property that's very key. What do you say?
Even is like it's symmetrical, whereas odd is like weird.
That was perfect. The wording was symmetrical, asymmetrical. It's actually exactly the same values, but just the opposite direction. So if you subbed in like x equals 1, it's 1, 1. But x equals -1, it's the same value, but just a different direction. So same magnitude, different direction. Same thing with a cube. You can cube 2, you get 8. But you cube -2, you get -8. Same value, different direction. Whereas in even powers, what you put in on the right side actually is exactly the same as on the left side. This is called symmetry property, and then that's asymmetrical property. One other key small feature which you may not be able to see, and I tried to do it very subtly in my drawing.
Like,
what's the difference as I went from 2, 4 to 6, and then 1, 3, 5?
They just get squared. I think it gets closer to 1 and
Very good. The squaring bit, so notice when I drew here, this is a bit flatter here, and that actually is the interval of -1 to 1. If you want to think about it algebraically, it's because you're doing to the power of 6, which is really huge, right? But when you look about between -1 and 1, it's a fraction. If you did 1 over 8 to the power of 6 versus 1 over 2 to the power of 6. Oh, sorry, I'll do 1 over 8 again, but squared. That's 6. Remember index laws? You would do this to the power of 6, you do that to the power of 2, but the bottom is what's key. This one would be 8 to the power of 6, which is really large. And this one will be 8 to the power of 2, which is not as large. But what's the problem if you have a very large denominator? Yeah, the number's smaller. Because it's essentially like saying if you got $1 and you share it for more people, if you share to 100 people, everyone gets very little of the amount. But if you only share to 2 people, each person gets a lot more. So the larger the denominator is a problem. The larger denominator, the smaller the values are. That's why between -1 and 1, the graph gets really flat because it's very small. But as soon as you pass 1, it shoots up. So if I showed you on Desmos, which I love, here's x squared, x4, x6, x98. Can you see? when it passes 1, the one that was at 98, it was the closest one inside because it shoots up really intensely. But in between, it's so flat because the denominator to the power of 98 is so small. That's why it looks really flat on the bottom, but it's symmetrical. All of them are symmetrical, which is why once you understand quadratics, then you understand quartics, then you understand anything that's even powers.
If we're relating it to x to the power of 98, does it ever touch the x-axis?
Yeah, it does. They all touch at the moment at 0, 0. Because when you do 0 to the power of 2, it's still 0. 0 to the power of 4 is still 0. 0 to the power of 6 is still 0. And 0 to the power of 98 is 0, 0. So they all touch at 0, 0. But if I wanted to make them all have an x-intercept, which is what we're studying today, you just change. If I did minus k, and I said minus k, minus k, minus k, you can see now the graph will be affected. It's all the same shape. But all I'm doing is I'm just changing how I'm shifting the graph up and down. And it's just based on that k. And that's what I'm teaching you today. So today I'm teaching you what those parameters do. So the shape stays the same, right? But what have I done? All I've done is I've just changed what happens to subtracting a value to the functions. These are called parameters. So today what you're going to explore in your notes is you're exploring how do each of these parameters affect that shape. So if I put a h in between them, you should be able to see something that happens to the graph. Or if I put an a multiplied to the function, what happens to the shape of the graph? That's what we're studying today. Okay? So that's a bit deep from where I'm going there. If you got it, great. If you didn't, don't worry about it. We'll start off with just quadratics today. But hopefully you got an overview. So the overview is anything to the power of 2 or largest power is 2. We know that's a quadratic equation now, so it's parabolic shape. Now we need to understand what does a, h, and k do. Working backwards from right to left, k is the easiest one to read, which is the one I just did with you guys. K dictates up or down. So if it's a positive k, so if you're adding on a value, so write this down, if you're plussing k, then it'll go up. If you minus k, it will go down. Okay, that's what the k's will dictate to the graph. So write that down. So first one is the easiest one to read is what you're adding or subtracting to the equation. You always got something squared, and then whatever you add or subtract to that equation will dictate whether it goes up or down. So let's go back to this one. If I said y equals x squared, so that's my parabolic shape. All I have to do now is I say plus a parameter. So k can be any number. And watch what happens. If k is positive 1, it's shifted up. So you notice it's shifted up to 1. Because the original graph was y equals x squared. That's where it was. But just by putting k equals 1, that means I'm doing x squared plus 1. It's shifted up by 1. Now if I just press play on the k value, then you can see all it does is the larger the value I go, the lower the value goes down. So when it's negative, it's down. When it's above 0, it goes up. Because that's all the k does. If you add the values, it shifts the graphs up. If you minus the values, it shifts the graphs down. And if you put k equals 0, then it doesn't move up or down. It just stays at the center. Yep.
So k moves the origin point in the higher or lower, right?
Yeah, the origin point is the easiest way to read it. So the minimum point there.
If it was like further down to the negative x-axis, if the k was like minus, it would still negative, right?
Yep. So let's take a number. Let's say negative 20. If we now look at where it is, the middle, that origin point is now at negative 20. We call that a turning point. That's the special name for it. So that specific point where it actually reaches the bottom and it goes back up, that origin point is called a turning point. Okay, so if you wanted to write it in, you can say in a property on a graph, that turning point is the easiest way to read turning point. That's the easiest way to read whether it's gone up or down from the x-axis. Okay, so up or down is based on plus or minus. Let's try another one. The second easiest one is your h. H, which I'm going to teach you. This is the only way I'm going to teach you. No one normally teaches this way. You won't find on YouTube. This is just me. This is how I teach my year 11s. See, whatever you square, is what dictates the shape, which is parabolic. But whatever you're squaring, this here is where the x normally occurs. This will dictate any changes to the x values, which means horizontal movement. So right here, I want you to write, how do you know if it moves left or right? So left or right? No. So this is where it's counterintuitive. And so I'm going to get you to memorize this. I want you to let whatever you're squaring, so in this case, it's x plus h. That's what you're squaring. So I'm going to highlight in green. I want you to let that equal to 0, then solve for x. Whatever x is, if it's positive, it will go to the right. So if x is positive, it goes to the right. If it's negative, it'll go to the left. No one will teach you this because I made it up, and it seems to help students to be able to read. Doesn't tell you why, but this is...
X is positive, so 0 would also be right. No, 0 would be the same.
Yep, that's right. And the reason why I teach it this way is because when year 11s get into the course, it's usually in your textbooks, they'll do something like x minus 1 squared, which if I asked you, does this move left or right? This is how you first figure it out. This is what you're squaring. Let it equal to 0. So it's x minus 1 equal to 0. Now solve for x. What does x equal to? Positive 1. So that means it goes to the right by 1. Okay, so if I showed you on the graph, this is what it looks like. So I'm going to just delete this one now. Y equals bracket x minus 1 squared. And I'll just press home again. Can you see that? It shifts the origin from 0 to 1. So it feels like it's moved to the right by 1. The problem is that a lot of students at year 10 and year 11 start memorizing this. If they see a minus 1, they say to the right by 1. If they see a plus 2, they say to the left by 2. The problem is that as soon as I change it to, in the question, if I put a 2 there, they still tell me it's going to the right by 1. And it's not true. It doesn't actually go to the right by 1 if I put a 2 in front of the x. But if you use the technique I just taught you, you'll be able to tell me where it moves to the left or right. So let's solve for this one now. If it was 2x minus 1, what would x equal to? How do you solve this? Good. Add 1 on both sides. That's a minus 1, so add 1 on both sides. You now get 2x is equal to 1. And you want to find x? Divide both sides by 2 because that's a times there. So divide both sides by 2. Now that's a positive half. So what does it tell you? To the right by half. And watch what happens. See if I go back and I put a 2 in front of it. It's at half. Okay, and that's where my year 11s and 10s, if they're not listening to what I'm telling them, how to actually find out whether you move left or right, let what you're squaring equal to 0 and then solve for x. I know it sounds weird, but not until you learn transformations you know why that works. Okay, but at the moment, that's how I teach my students, and then they can work out if it moves left or right just based on whatever you're squaring. That's what affects the x component. So let that equal to 0 to work out whether it moves left or right. Okay? So that's the second hardest one to read, although your textbooks will be pretty easy to read at the moment. So k is up or down. Whatever you're squaring, let it equal to 0. If it's positive, moves to the right. If it's negative, moves to the left. Okay, so I'm going to show you by putting a plus h. I'm going to put a parameter, and you'll see how the graph shifts left and right. So watch this. I go back here, x plus h, put in my parameter, and here we go. When I press play, you can see the graph goes left and right, but when it's negative, it goes to the right. Watch what happens when it goes to positive now. When h is positive, it moves to the left. So it feels like it's the opposite, but just be careful. I haven't put a number in front of x. Once I put in front of a number x, it changes things. That's why I'm telling you to let whatever you're squaring, let it equal to 0, then solve for x. That's the way to do it. Okay?
So x plus h equals 0 would make it the same. X plus h. If x plus h is positive, then it's to the right. And x plus h is negative, then it's to the left.
No, if you let x plus h equal to 0, and then when you solve for x, if x is positive, it will go to the right. And if x is negative, then it goes to the left. So the key part is solving for it. You have to solve for x, and if it's positive, it will go to the right. If you solve for x, it's negative, it will go to the left. Okay? And then the last one. This is arguably generally the trickier one, once you learn dilations, but at the moment you guys don't know dilations. So the way I teach my students is I say, if the number is bigger than 1, it's narrow. So it gets really thin. If the number is a fraction, so less than 1, 0 to 1, it's wide. So we'll make the shape much wider than it would actually look like. Okay? And the reason why it's tricky to remember is because there's 2 components. It dictates whether it's going to be narrow or wide, but A also is if it's positive number, then it will be a smiley face. So I normally tell my students, when you feel positive, you smile. And when you're negative, feeling negative, you frown. Okay, so that might help you remember it. When A is positive, so you can have a positive and thin frown. Sorry, you can have a positive and thin smile, or you can have a wide smile. You can have a thin frown and a wide frown. But what dictates a frown or a smile is based on whether it's positive or negative. Okay? So watch what happens now after you copy the notes. So larger than 1 makes it narrower. Between 0 and 1 makes it wider. Positive is smile. Negative is frown.
You said when A is bigger than... Wait, I'm confused. What happens when A is a negative? Like, talking about narrow and wide.
Yeah, so narrow and wide is just based on the value. The sign of the number dictates the shape. So if you had a positive 1, or sorry, a positive 3, then it's thin and it's a smile. But if you had negative 3, then it will be thin, but it is a frown.
So a negative will make it thin?
No, negative will make it frown. But the value, so if the number of the value A, so the number in front, what are you multiplying? If the number is bigger than 1, it's thin. So like 3, 4, 5, 6, 7, 8, 9, 10. Those numbers will make it thin. But if it's negative 10, then it'll be thin, but just upside down. So it's not the value, it's the sign. You know what I mean? So this is value, this is sign. So the first question is if you want to know if it's this shape or whether it's this shape, because they're both parabolic. It's just whether it's a frown shape or whether it's a smiley shape. It's just dictated whether it's positive or negative. It doesn't matter about the value. The value, though, will dictate whether it's thin or wide. The larger the number, the more narrow it is. The smaller the number, fractional, the wider it is. Okay, so I'll show you on Desmos now. So let's say...
Oh, so even if it's like a negative 3, it'll still be narrow.
Yeah, but frown. Yeah,
Okay.
that's right.
So it doesn't matter about negatives or positives when you're talking about narrow.
That's right. That's exactly it. So here's an example for you to see. I took off the H and I took off the K and I just focused on the A there. So the number of times in x squared, right now it's 1. So it actually sits the same as the previous equation. But notice when I change it to 2, to 3, to 4, to 5, to 6, to 99, it's getting thinner. Yeah, so it's getting, what's actually happening is you're pulling the graph vertically. And it's getting thinner. Okay? Whereas if I change that to now decimals, less than 1, so 0.99 to let's do 0.8, 0.7, oops, 0.7, 0.6, 0.5, 0.3, 4, 3, 2, and then maybe 1.5. Can you see how it's getting wider? Right? But I can still have the same width, so it can still be 0.15, but flip it. So that's currently a smiling shape. If I put a negative in front of it, it now becomes the same shape, but flip. So it's still wide, it's upside down. So the value dictates whether it's thin or wide. The sign dictates whether it's smile or frown. So far, so good?
Yeah.
Okay, so there's 3 components there to look at. So let's now put it all into practice. Let's see if you can read an equation, okay? So let's, we'll fill out these points soon. Let's do a practice so that you get a good feel of it. Let's do this one. Just flip over to the next page. Let's look at example 2. Let's see if you can read it now. First equation. You can tell it's an x squared, so it's parabolic. So you already know it either looks like this or looks like this. Is it a frown or is it a smiley shape? Smile. Why? How do you know? It's positive number in front of x squared. Even though I don't write it, it's actually a positive 1. So A is currently positive 1, so it's a smiley shape. Is it thin or wide? Neither. Okay, so if it's just 1, it stays the normal shape. Okay, so when you draw it, if it's smaller than 1, like a fraction, then make it a bit wider. And if it's larger than 1, make it a bit smaller. But if it's 1, just draw a normal shape that you normally would. Okay? So this is normal shape, not thinner or wider. That's what A tells you. Does this have any left or right movement?
Yes. 7 to the right.
No. Remember, it's what you're squaring dictates whether you move left or right. Now, what are you squaring? You're squaring x. So that, if you want to know if it moves left or right, you let what you're squaring equal to 0.
What happened to the height?
Yeah, because the h isn't there. So another way of writing this is x plus 0 squared. That's your h. But we wouldn't write x plus 0 because x plus 0 is just x, and then x squared is that. So being able to read this bit here, that's why it's the second hardest one. That one, whatever you're squaring, so I've highlighted in green, whatever you're squaring, that dictates left or right. Not the plus 7. Plus 7 is separate from the squaring. Yeah, so this one is actually telling you what? What's the plus 7 tell me? Up. Very good. That's your k value. Okay? Not what you're squaring. So here, plus 7 is up. You're going up by 7. But what you're squaring is the x. But unfortunately, there is no h value because technically it's 0. So if it's 0, it doesn't move left and it doesn't move right. So if I asked you what this graph looks like, I can already say no right or left. So it stays at the origin, but it goes up by 7 and it's a normal shape. So it should look something like this. X squared goes up by 7. It's a smiley face, doesn't move left or right. So if I put it in here, if I actually typed it in, x squared plus 7. There you go. Goes up by 7. So you can see that this is your original graph. There you go. All we did was we said, doesn't move left or right. It's clearly a smiley shape. And the plus 7 shifts it up by 7. But if I wanted to move left or right, it's what you're squaring. You would have to change. Yeah, so inside it, whatever you're squaring, you have to then say that. That's the only way to move it to right or left. Okay? Let's try another one. What's this one? This example. What's my a equal to? -1. So what can we say? Frown. Very good. When you're negative, you frown. Is it thin, wide, or normal?
Normal.
Normal. So you draw a normal frown shape. Does it move left or right?
None.
Very good. Stay still because what you're squaring is the x. Okay, another way, if you break it apart, this really just means -1 times x squared. And there is no h value there. So it doesn't move left or right. So no left, no right. Then what does a plus k or plus 3 do? Up 3. So we have to sketch this graph now. It's a frown, goes up by 3, doesn't move left or right. So it goes from the origin, goes up to 3, and it's a frown. That's what -x squared plus 3 should look like. And that's just basing on reading the graph there. What about the third one? What can we say about the third ones? Is it a frown, smiley face? Which one is it? Smile, because the number that's multiplying to what's x squared, even though I don't write it, it's actually a 1. So a is equal to +1, so it's a smiley shape. Is it thin or wide? Or normal? Normal, very good. So normal U shape. Very good. Now notice what you're squaring is the x minus 2. Does this move left or right?
Left.
We'll be careful. To the right, and how do you know? What do you have to do?
Solve for x.
Solve for x. So let it equal to 0, x minus 2 equal to 0. Solve for x. 2 is currently +2 because you have to add Add 2 on both sides. If x is positive, it moves to the right. So notice, ignore the square. He's only taking what you're squaring. So it's the x minus 2, let that equal to 0.
Oh, I solved the whole thing.
Yeah, don't. Yeah. Just that bit. So whatever you're squaring, let that equal to 0. Solve for x. Tells you to the right by 2. Does it move up or down?
Nothing.
Nothing. So it doesn't move up or down because I didn't have a plus k value. Technically, I'm plussing 0. So this shape only tells me it's a normal shape. U moves to the right by 2, and it should look something like that. Doesn't go up, doesn't go down. So that turning point is currently at 2, 0. And yes, we do have to work out the y-intercept, but that's for later. Today's lesson is only just to read the shape of the graph. So your ability to be able to look at an equation and tell me what happens to it. Now, this is a combination of them all. Have a go. I want you to roughly sketch it now. Roughly sketch it. Doesn't have to be exact, but I need to have the correct turning point. The turning point should be correct. So have a go with this one. Yep. Oh, YouTube? No, it's a game. To the left. Good. Beautiful. And to front. Yeah.
That's it?
Yep.
Let's go.
That's it. Beautiful.
How'd you win?
Very good, very good.
On your fourth mate and one? Really?
So first thing you should have got is it's negative, so it should be a frown. It's normal. What you're squaring is the x plus 5. So let it equal to 0 and solve for x. Turns out to be negative 5, so it moves to the left. 5. Team, can we not do that while I'm teaching, please? Thank you. K equals negative 7, so it means down 7. So if you had to sketch it, I expect you to have something like this. Left by 5, down by 7. Turning point is at negative 5, negative 7. So negative 5, negative 7 is the turning point, and it's a frown. So it should look, well, that's a bad shape, but let me do it again.
You got the set.
There we go. Yeah. It looks something like that. If you got that, well done. That's the essence of what I want to teach you today. That's the shape of the graph, so you should be able to read what you're multiplying, what's the addition or subtraction, and then what are you squaring. Those dictate how the shape changes. That's exercise 7A. Now, if you flick back to the first page for me, I'm just going to give you some terminology so you're familiar. Flip back to the first page. Very good. There are 3 key features. You always need turning point, x-intercept, which later on we'll practice doing, y-intercept. Yeah, we'll talk about the axis symmetry here. So, when you sketch a graph, the one that we just did, so the example that we just did before was negative 5. So 1, 2, 3, 4, 5. Negative 5. 1, 2, 3, 4, 5, 6, 7. The turning point is negative 5, negative 7. Well, notice that that also is the line of symmetry. Where x equals negative 5, that's where it cuts the parabola in half. That's where it's symmetrical. That's the origin. So, we give that a special name. The vertical line that splits the parabola symmetrically is called axis of symmetry. And usually it is found where the x coordinate of the turning point is. So in this case, the axis of symmetry, which I'll draw in green, if I had to cut it vertically down, it's when x equals negative 5. That's the equation. So when they say, what is the equation of the axis symmetry? That's what you have to write. You have to write x equals -5 is the vertical line that cuts the parabola in half. So if I did it on Desmos so you could see, y equals negative x plus 5 squared minus 7. Here's your graph. Here's your turning point, -5, -7. So we've labeled it. There's -5, but notice where's the axis symmetry? X equals -5, cuts it down. So that's the vertical line. I'm just going to change the color and put a dotted line so you can see. See that vertical line? That vertical line cuts the parabola in half. That's called the axis symmetry. But how did I get it? I literally typed the equation. X equals -5, and that was the x coordinate of the turning point. That's where we cut it in half. So knowing where the turning point is useful because you know where the symmetry is. Okay, that's where the origin is. There we go. And last thing, when I said frown and smiley face, there's a proper name for them. When you have a frown, we call that a maximum turning point. That's right. And then when it's a smiley face, we call it a minimum. That's right, because it gets to the lowest point before it goes back up. So that's the proper names for them. Or if you're talking about the shape, you would say upright, inverted. So this one's called inverted. Inverted, upright. So if you want to describe the shape, you would talk about inversion or uprightness. The name for it is minimum turning point or maximum turning point. You either reach the maximum value you can have and it comes back down, or reach the minimum and it goes back up. Okay? Yes, I know. So this is when A is negative, and this is when A is positive. And that's it for exercise 7A, team. That's what you need to know. So you've learnt all the parameters that go with how do you move the left and right. I haven't taught you the algebra to solve for x-intercept, y-intercept yet, but that's where chapter 5, chapter 7 is about. You then learn how to solve for x-intercept, y-intercepts. Okay?
Turning point.
Oh, TP.
Oh, sorry, yeah, TP, turning point.
Oh, it's like a TP.
TP.
Yes, it is.